Hello friends, welcome to Wisdom Training's Hadoop Developer course. In this video, we'll be studying Pig framework. So this is the logo of Pig framework here with me. So the question arises, why are we even talking about Pig framework when we already have mapreduce in hand, right? So there's a very strong reason behind this as well. So that strong reason is the programming language called as Java. So there are folks from different various backgrounds who want to learn Hadoop, but they are afraid of Java, or they do not have good knowledge in Java or in the programming side, right? So they are afraid of programming, and they run away from this stuff, and they think that they cannot work on Hadoop. So there's to break that ice, to make the people enable from various backgrounds. This project was taken up at Yahoo, wherein they developed a Pig framework called as Pig, which had a language called as Pig Latin, which is very easy to learn and understand, and you can quickly start working on Hadoop without having prior knowledge of Java even. Alright, so if for those folks who are not good in Java, or who do not have any knowledge of Java or any other programming language, need not worry here, they can also work on Hadoop. So for them, the thing called here is Pig framework, right? And you'll be amazed to know, so if I have a job, or if I have an application which requires 200 lines of Java code, the same thing or the same application can be written in Pig with only 10 lines. So can you imagine? So 200 lines of code can be replaced by the 10 lines of Pig statements, or the Pig Latin statements. So this is very very good. It's very easy. It will be very easy to learn, and we must learn actually, right? We must learn this, because here the complexity is reduced, right? So this Pig Latin provides a huge level of abstraction, wherein you just need to write the statements, but at the back end, mapreduce job is run only. Okay, what Pig framework does is, hold on. So you write the code, or you write the Pig Latin statements here. Pig Latin. So this is a language for Pig framework, very easy, similar to SQL. So it's SQL like. Alright, so you write Pig Latin statements, but at the back end they are converted into mapreduce job only. Okay, so mapreduce job is run at the back end, and the application is processed, or the job is processed. But you need not worry what is being happening at the back end. You are just concerned about the front end. You will just write the statement, and at the back end, mapreduce job will be there for processing that job, or framework will convert that into a mapreduce job and will do the task. So we need not worry about learning some Java code here, right? So we will be just learning Pig Latin statements. Very easy to learn, very easy, right? You can quickly start working on Hadoop with this, right? So this was a major reason why this was developed, right, and why we should use it. Okay, so to enable people from the various background to work on Hadoop. So why should we go for Pig when we have mapreduce? It's a faster development. Another thing, so when you have lesser lines of code, you will obviously take less amount of time to write the same application. So you'll be amazed to know the total time taken for writing an application is in Pig is 1/16 of the time taken in the mapreduce for writing the same application in the mapreduce, right? So it's 1/16, and the total lines of code are 1/20 of what you write in mapreduce. So less lines of code, faster development, and easier to learn and understand. And Pig Latin provides a high level of abstraction, which makes Pig easier to learn and read. So you're avoiding Java here. Okay, for those folks who run away from the programming language called as Java, this is the thing they must learn. Right. Moving forward, so why do we need Pig, and what are the features of the Pig? So as I already discussed, it's a quick little poker, right? Which means it do the stuff very quickly, wherein you have 1/20 of the lines of code and 1/16 of the development time, as compared to writing a raw mapreduce program. Another thing of very important, it can eat anything, as Pig eats everything, right? So it doesn't see what is going into its stomach. Similar to the stuff, this Pig, it eats everything. What do you mean by everything? Any kind of data type, any data, any data here, that is structured data or unstructured, as well as semi-structured. So any kind of data can be eaten up by or processed in Pig framework. So it eats everything, so therefore the name Pig has been introduced. Okay, the Pig does more with less, right? So it has common functionalities in it, wherein you can form the joins. You can join two data sets and then have some filtration there. You can group them. So it kind of already built-in functions are available. You need not worry how to do that. If that thing has to be done in MapReduce, it is very complex. Joining and then filtering it and then grouping it, it's very complex in Java, but in Pig it is very easy. You just have to write a single keyword which will be grouped by or filtered by, and you can do the stuff very easily. Alright, it also has nested data types, that is tuples, bags and maps, that I'll be discussing here, which is not available in MapReduce. Alright, we'll be talking about these nested data types here only, but a little bit after this, right? So it's a quick little poker. It eats everything and does more with the less. Coming to the next slide, it almost anyone can write here, right? So the same stuff, the people from the various background who doesn't have knowledge of Java can also work on Hadoop using Pig, right? So it's easily writable. So it's a Pig Latin that actually makes sense. So it is a series of step-by-step statements. So wherein you first load the data into Pig framework, then do some extraction or filtration over there, and then you dump or store the data, right? So it's a series of statements that has to be followed. You load the data into the framework, and then you do some you apply some logic, you do some filtration, you do some joins, groups and etc., and then the final result is stored into a variable, and then it's dumped into a file or into an HDFS, right, or onto the console itself, right? So it's not afraid to play with the snakes. Sometimes the built-in functions they do not suffice to your requirements, and you need to write something of your own, right? So you have some function or you have some requirement which is not available inside the built-in functions. You can write your own function, that is user-defined function in Java, Python, Ruby script or JavaScript, and you can use that UDF function in Pig and do the analysis or do the processing of the data, right? So this thing is also available here. That is, it can play with the snakes. It helps you sleep at the night. So if there are changes in the Hadoop or there are some updates in the Hadoop Java API, you need not worry about them. Your code will still run, that is your Pig Latin statement will still work. You need not worry. So you can sleep you can have a good night's sleep. Okay, its most popular Pig. It is being used at very major companies here. If you see here, you have big names: LinkedIn, Twitter, Salesforce and Stanford University and many more. So the big names are there. LinkedIn is using Pig, Twitter is using Pig, and Salesforce is using Pig, right? And you have intensive in a community which is working on Pig. You can get the support, right? So Apache has officially taken it into its account. So Apache Pig is available. So the project is Apache Pig. It was developed by Yahoo, but it is being taken care by Apache now. Alright, so it has a lot big time users: LinkedIn, Twitter, Salesforce and Stanford University, etc. Alright, so these are the major features of Pig Latin or Pig framework, I must say. Alright, now coming to your where to use Pig. Okay, so what all things or where we can use Pig. So when you have to process the data from various data sources, let me tell you an example here. For example, you have data source from a different you have your data from the different data sources. That is, you have your data from ERP, that is enterprise resource planning, and then you have your accounting here, and let's say you have flat files. Okay, so these are your data sources and you want to process these data. Okay, so what you will do is you will load the data or extract the data here, and you will do some transformation in the Pig. So what kind of transformations can be done here? you can do some kind of data validation. Alright, there must be something, sometimes your data from the ERP accounting and flat files of a single organization, there can be some redundant data, so removal of redundant data can be done using Pig framework. And let's say there are some errors, so I can write here error fixing. Okay, and you must also be wanting encoding, so encoding can also be done using Pig, and the final result is dumped into or stored into your data warehouse. Alright, so this is your Pig framework. Alright, okay, so basically it's kind of ETL only, that is extraction, transformation, and loading. So ETL, so you're extracting the data from the various data sources, that is ERP, accounting, flat files, and you're doing some transformation, that is you're doing some data validation, removing the data, filtering the data, grouping the data, you're fixing some errors there, you're encoding the data. So kind of complete transformation of the data is happening here in the Pig framework, and then you're loading it to some other, that is you're putting it into, or dumping it into, or you're storing it into a data warehouse, or you're storing it into HDFS, or you're storing it into another file. Okay, so this is a kind of where you have these kind of scenarios, that is you have to process from the various data sources, you can use Pig here. Okay, and then you have analyzing a part of data, that is called as sampling. So for example, you have a huge data set here. Okay, hold on. So you have a huge data set, this is a data set, and you want to process only a subset of this. This is the data you want to process, so this is subset of the complete larger data set, right? So what do you do? So in this kind of scenario, you can use Pig, wherein you can filter the data out of this larger data set, and then you can do the transformations, and you can process the data very easily, right? So this taking a small part from a larger data set is called as sampling. Alright, also it can be used wherein you have time sensitive data loads, right? Wherein the time is very sensitive, the time is very important for you, you can use this Pig in those kind of scenarios. So processing data from various data sources, those kind of scenarios you can use Pig. And when you have to analyze a part of data, that is sampling. And wherein another thing is you have time sensitive data loads, so where the time is very crucial, you can use Pig, wherein you need to deliver the results faster. So the Pig will help you write the code faster and do the analysis faster, right? Now moving on. So what is Pig? It's a platform for analyzing large data sets. So Pig language, it is Pig Latin, is a simple query algebra that lets you express data transformations such as merging data sets, filtering them, and applying functions to record or group of records. So users can create their own functions, that is called as user defined functions. So it's a framework or a platform, right, for analyzing large data sets, right? Now, okay, so what is the anatomy of Pig? You have main components of Pig are the Pig Latin language, very important. Then you have an interactive shell wherein you write the data statements there, alright? So that is called as grunt shell, okay? And then you have Pig interpreter and execution engine, which actually interprets the Pig Latin language and converts it into a mapreduce job, and then ultimately the mapreduce job is run on the data that you have provided. Right? So you have a data flow language that is called as Pig Latin, and an interactive shell wherein you type this Pig Latin statements in the grunt shell, and you have Pig interpreter and execution engine. So I have a picture available with me in the slides. Okay, so you write Pig Latin script, that is if you see here, the example is given. So you're loading the data into the Pig framework, you're loading student, you have to load the data along with the schema of the data, right? You have to load the data along with the schema of the data. So you load student, roll number, name, GPA. This is a kind of schema that you're giving to it, and then you're doing some filtration, and then you're dumping for each age generate upper, that is it is changing the name field to uppercase, right? So they will be changed to capital letters, and store it into a report, that is my report. into a file, right? So this is a pig interpreter. You're writing simple statements on the grunt shell. So this is your grunt shell here. Okay, so this is a pig Latin script. You're writing it in the grunt shell, and the pig interpreter, what it does is it processes or parses the pig Latin, and it checks for the data types, right, and performs the optimization, and then create mapreduce job. This is the ultimate stuff that it does is creating a mapreduce job, and then submits the job to mapreduce and monitor the progress. So mapreduce jobs are run on the Hadoop, right? So this is the flow, right? So you write the code, or you write the statements on grunt shell. These are interpreted by the pig interpreter and execution engine, and then these are ultimately the mapreduce jobs are submitted on Hadoop, and they are run and the processed, and the result is obtained here. So you can dump or store the result. Alright, so this is the anatomy of pig. Alright, now moving on. So pig on Hadoop, pig runs on Hadoop. It uses both HDFS and MapReduce programming, as I already discussed in the previous slide. So here you're using MapReduce, and here you're using HDFS and Hadoop. Alright, I mean Hadoop has two main components, that is HDFS and MapReduce. So pig is dealing with both MapReduce and HDFS. Alright, so it is running on top of Hadoop. So if you say you have your Hadoop here, and you will have your pig here, which will be running on top of Hadoop, right? So it's interacting with Hadoop. Alright, so it reads the input files from HDFS and also stores the intermediate and output in the HDFS, and it can also store the data on external resources as well, right? So here external resources can also be there. You can also read the files from the external sources, and it can also read the files from HDFS. I can write here HDFS, that is Hadoop Distributed File System, and it can also read or write to external sources and read and write to HDFS as well. So pig runs on top of Hadoop. Alright, now what's the basic program structure in pig? You have your grunt shell. Either you can write the statements in the grunt shell, or you can make a script out of those statements, that is called a script file, right? So all this or all the pig Latin statements can be put into a file and given a extension or correct extension for a pig Latin script, and then you can execute directly the pig Latin script. What's the use of pig Latin? The script is you can schedule the jobs. For example, you have a script here. Let's say job dot, I'm just giving a name here, pig here. So this is my script, right? So you want that this script should run every week on Sunday. Okay, so every week on Sunday this should run. So there is a framework that is called as Uzi, which is a workflow scheduler, which can help you schedule the jobs. Alright, so you have your script, you give it a time that on this point of time this script should run. So OZ will help you do that. So you have your grunt shell, wherein you write the data or the SQL like statements, that is pig Latin statements. This is used for ad hoc data analysis and program development. Alright, and if you have some job to run every now and then, you can do that using the script file. Okay, and then you can schedule the jobs using the Uzi. Okay, and then you have embedded queries with Java. There are certain functions that are not available or which are not suiting your requirement. You can write your own functions, and you can make your user defined functions, and you can then run that, right? So that is also another programming basic program structure that is available in the pig, right? Okay, moving on. So you have 4 basic data types of data models here. You have your atom, then you have your tuple, you have your bag, map. So let me just explain you with the help of an example here. Will we get it more clearly? Let's say you have something called as, we have the names of employees. So John, tab, John is there, then you have Harry, then you have Potter. Okay, so I'm assuming that Harry and Potter are two different employees. Okay, and then you have Ron, okay, and you have Ted, you have Robin. So the each individual piece of data, that is John, Harry, Potter, Ron, Ted and Robin, these each one of them defines an atom. So each one of them can be called as atom. So the smallest piece of information, I can say the smallest piece of information can be termed as atom, right? Then talking about tuples, so it's the combination of different atoms, right? Or combination, I mean, it's a collection of different atoms. Let's say John, comma, Harry. So they're the friends. So it is then surrounded by circular brackets, right? So John and Harry, this item now corresponds to a tuple. Okay, so if I talk about bag, a collection of tuples is called as bag. That is, you have your John, comma, Harry. So these are best friends. So this is a bag which is representing the best friends here, comma, Ted and Robin are the best friends, and this is surrounded by curly braces. So this is your bag. So this stuff, this piece of information is represented as bag. You'll get to know why do we require this in the coming parts or coming videos, right? So this is your bag. And if you talk about map, this is a key value pairs. Okay, so you have your key value pairs here. So your key will be representing, for example, let's say it's a name, and the key is represented by hash, name hash Ted. So Ted is the name. So now name is the key, right, and Ted is the value. So it's a key value pair, name hash Ted. Alright, so this is called as map. So you have four basic types of data models, that is atom, tuple, bag and map. Correct? Alright, now moving on. So if you talk about data models, can be defined as follows. A bag is a collection of tuples. Tuple is an ordered set of fields. A field is a piece of data, and a data map is a map from keys that are string literals to values that can be of any data type. That is, your key can only be of string data type or the char array, but your values can be anything of any data type. There is no restriction, but your key has to be of char array data type. Alright, so this was all about Pig introduction, right? You'll see in the next coming parts. For that, you'll have to buy the videos. Thank you.